Section 1. A Cosmic Address. Our place in the vastness. Where do we live in space? This is a question that has echoed through human history, whispered around campfires and shouted from the tops of observatories. The answer, as we have come to understand it, is beautifully simple and profoundly complex. We live on a planet, a fragile blue sphere called Earth. But Earth is not an island adrift in an empty void. It is a member of a vast and intricate family, a cosmic neighborhood bound together by the immense gravitational pull of a single star. This family is our solar system. Moons, asteroids, comets, all dancing in an ancient, silent ballet around a central, fiery heart. Understanding this system is the first step in understanding our own place in the cosmos. To ask, where do we live, is to begin a journey of discovery that takes us from the familiar ground beneath our feet to the unimaginable distances of deep space. Our immediate cosmic address is this solar system, a gravitationally bound system comprising the Sun and the objects that orbit it, either directly or indirectly. It is a place of incredible diversity, from searing hot, rocky worlds to frigid giants of gas and ice. Section 2. The heart of the system. Our star, the Sun. At the absolute center of our solar system, commanding 99.8% of its total mass, reigns our star, the Sun. It is not merely a bright object in the daytime sky. It drives weather. It enables photosynthesis. It makes life on Earth possible. The Sun is a star, a gigantic searing ball of hot gas, mostly hydrogen and helium, held together by gravity. Its immense size is staggering. You could fit more than 1 million Earths inside it. The light and heat it radiates are not a simple fire, but come from a far more powerful process deep in its core. This process, nuclear fusion. In the core, temperatures reach 15 million degrees Celsius. Hydrogen atoms are crushed together and fuse into helium. That releases colossal energy. E equals mc squared. Energy travels outward through the radiative zone, then the convective zone, until it bursts from the photosphere as light and heat. Section 3. The inner world's rocky neighbors in the Sun's glare. Venturing out from the Sun's fiery embrace, we first encounter the 4 terrestrial, or rocky planets, Mercury, Venus, Earth, Mars. Composite image showing Mercury, Venus, Earth, and Mars side by side for scale. These are the inner worlds, forged in the hotter, denser region of the early solar system, where only materials with high melting points could condense rock, metal. They are relatively small and dense with solid surfaces, a stark contrast to the giants beyond. The first of these is Mercury, the swiftest planet, completing its orbit around the Sun in just 88 Earth days. Mercury's sun-facing side can exceed 400 degrees Celsius. Mercury's night side plunges to about minus 180 degrees Celsius. It has almost no atmosphere to trap heat. Section 4. The outer giants, gas and ice in the cold expanse. Crossing a vast expanse of space beyond the orbit of Mars, past the rocky debris of the asteroid belt, we enter the realm of the giants. These are the outer planets: Jupiter, Saturn, Uranus, Neptune. The first and most formidable of these is Jupiter, the undisputed king of the planets. It is a gas giant, a colossal sphere of hydrogen and helium so massive that it contains more than twice the mass of all the other planets combined. Jupiter has no solid surface to stand on. Its colorful cloud bands are the tops of immense weather systems, including the famous Great Red Spot, a gigantic storm that has been raging for centuries and is larger than Earth itself. Jupiter is like a miniature solar system, presiding over a complex cord of at least 95 known moons. Io, volcanically active and the most geologically active object in the solar system. Europa, with an icy shell believed to hide a vast, salty ocean beneath its surface. Ganymede, the largest moon in the solar system, even larger than Mercury. Callisto, the heavily cratered moon offering clues about formation and evolution. Continuing our journey outward, we arrive at Saturn, the jewel of the solar system. While it is another gas giant composed primarily of hydrogen and helium, Saturn is most famous for its breathtaking system of rings. Countless particles of ice and rock, from dust grains to house-sized chunks, forming a vast, incredibly thin disk. Section 5. The far reaches, beyond the planets. The story of our solar system does not end with Neptune. Beyond the orbit of the last giant planet lies a vast, cold, and dimly lit frontier populated by countless smaller objects, remnants from the solar system's formation. The first region we encounter is the Kuiper Belt, a donut-shaped ring of icy bodies extending from just beyond Neptune's orbit out to about 50 times the Earth-Sun distance. This is the home of the dwarf planets, large enough to be rounded by their own gravity, but not to clear their orbits. The most famous resident of the Kuiper Belt is Pluto, reclassified as a dwarf planet in 2006, revealed in 2015 as a complex world with nitrogen ice glaciers, water ice mountains, a thin atmosphere, and youthful plains. Pluto is not alone. Other large dwarf planets include Eris, Makemake, and Haumea. Between Mars and Jupiter lies the main asteroid belt, a vast, mostly empty region of millions of rocky and metallic bodies. The largest Ceres is a dwarf planet with enigmatic bright salt deposits revealed by dawn. Comets, dirty snowballs of ice, dust, and rock, hail from the Kuiper Belt and the distant Oort cloud. Heated near the sun, they form glowing comae and iconic tails pushed by sunlight and solar wind. Section 6. A Cosmic Genesis, the story of our solar system's birth. How did this magnificent, orderly system of planets, moons, and stars come to be? The story of our solar system's formation, known as the nebular hypothesis, begins about 4.6 billion years ago with a vast, cold, slowly rotating cloud of gas and dust, mostly hydrogen and helium, enriched by heavier elements from earlier stars. A nearby supernova shock likely triggered collapse. As it contracted, it spun faster, like an ice skater pulling in their arms. The cloud flattened into a spinning protoplanetary disk. At its center, fusion ignited. Our sun was born. In the hot inner disk, metals and silicate rock condensed. Tiny grains stuck together through accretion, growing from dust to pebbles, boulders, and planetesimals. Over millions of years, 4 rocky protoplanets formed amid chaotic collisions: Mercury, Venus, Earth, and Mars. Beyond the frost line, water, ammonia, and methane ices made abundant solid material. Massive cores captured hydrogen and helium, forming gas giants, and farther out, the ice giants. Thus emerged the fundamental division we see today. Section 7. The Human Quest, exploring our celestial backyard. The solar system is not just an abstract concept, it is a physical place. We have begun to touch, we have begun to taste, we have begun to explore. For millennia, humanity could only gaze at the planets. The 17th century telescope opened a new window: moons orbiting Jupiter, the rings of Saturn, the phases of Venus. The space age let us break Earth's gravity and send robotic emissaries to see these worlds up close, transforming myth into tangible places, landscapes, weather, geology. Our robotic explorers are our eyes, our ears, our hands, driving miles, analyzing rocks, and hunting chemical fingerprints of past life. Subsurface oceans on Europa and Enceladus. Pluto's surprising youth. Returned samples from Ryugu and Bennu. Each answer raising new questions. Next, drill Mars, sail Titan seas, taste Europa's plumes, and send humans to Mars. So, where do we live in space? We live in a solar system far more wondrous and complex than our ancestors imagined. It is our home, our cradle, our laboratory, and our exploration has only just begun. Future missions plan to drill into the Martian subsurface, send a submersible to Titan seas, and fly through Europa's plumes. The dream of sending humans to Mars is becoming a tangible engineering goal. There is so much more to learn, so many more secrets to uncover. The solar system is a book with countless pages yet to be read. As we continue our quest, we better understand the cosmos and ourselves.